Okay guys, now we proceed with second example, which is exercise 3.10a, page 112. So please refer to your textbooks. So I just rewrite the question back. So you were asked to find the general solution of y double prime plus y prime minus 2y is equals to x plus 2 ex. Okay, so as you can see on your right hand side, your fx is a combination of polynomial and exponential. Okay, a product multiplication of polynomial and exponential. So actually this one can also be solved by using UC, but this one is case 5 I think. Okay, so but since we just cover UC up until case 3 where your fx is a trigonometric function, therefore if you have a linear combination or a product multiplication of case 1, case 2, or case 2, case 3, so you need to use BOP. Okay, so we are going to solve this one. So first step is you have to find your YH by assuming your fx is equals to 0. So therefore you will have y double prime plus y prime minus 2y is equals to 0. So express this one into characteristic equation will give you m squared plus m minus 2 is equals to 0. So therefore your m1 is equals to 1, your m2 is equals to negative 2. So again this is case 1. Okay. Why case 1? Because you have different roots. Different roots. Okay. So therefore your general solution for YH is given by AEX plus BE negative 2x. Okay, so define your y1 and your y2. So rewrite it as AY1 plus BY2. So you know that your y1 is equals to exponent x and your y2 is equals to exponent negative 2x. Okay, so steps 2, you need to get your Wronskian function w. So define your y1 and y2 and differentiate it. So y1 is equals to exponent x, y2 is equals to exponent negative 2x. So differentiate y1 will give you exponent x, differentiate y2 will give you negative 2 exponent negative 2x. Okay, so next get the w Wronskian function by using y1, y2, y prime 1, y prime 2, which is equals to ex, e negative 2x, ex negative 2, e negative 2x. Okay, so therefore you will have your w is equals to, so this one times by this one, you will have negative 2 ex multiplied by e negative 2x minus ex times e negative 2x. So expand and simplify. Therefore, you will have negative 2. So exponents times by exponent. So you have to add the power. So you will have e negative x minus. So the same thing here. You will have e negative x. So therefore your w is equals to negative 2, negative 1, which is negative 3 exponent negative x. Okay, so next you need to find your u and v. Okay, but before that you have to identify what is your a and fx based on your differential equation. Okay, because you're going to use these two to calculate u and v. Okay, so the given differential equation to you is y double prime plus y prime minus 2y is equals to x plus 2 exponent x. So you know that your e is equals to 1 and your fx is equals to x plus 2 exponent x. So therefore you can calculate your u and v. So you will have u is equals to, so negative y2, so your y2 is equals to exponent negative 2x, exponent negative 2x times by your fx. Your fx is equals to x plus 2 ex over your e is equals to 1 and your w is equals to negative 3 exponent negative x dx. So here your constant is 1. So the next step is try to simplify this one first, exponent exponent. Okay, so first factorize the constant. So you have 1 here times by negative 3. So actually your constant here is negative 1 over 3. Okay, so factorize negative 1 over 3. Therefore you will have 1 over 3 because this one here you have a negative sign. So negative negative will give you positive. So here you have e negative 2x times ex. So when you have a multiplication of exponential function, so you have to add a power. So you will have negative 2 plus 1, so you will have negative 1, so negative x over x plus 2. So for the denominator here you have e negative x. So if you want to bring this one up here, so you will have ex, or you just can remain it as e negative x dx. Okay, and use the properties that I give you in the previous example, whereby if you have ea over eb, so this one is equals to ea minus b. So therefore in this case you will have 1 over 3. So integrate, if you bring this one, so you will have negative x minus minus plus x, and you will have e negative x minus negative x plus 2 dx. So negative negative positive, negative 1 positive 1, you will have 0. E0 is equals to 1. Okay, so this one is equals to 1, or you can simply cancel out from here. This one is equals to 1. Okay, either one. If you choose to do it straightly, so you can just cancel out this one, so you will have 1 here. So therefore you left with integrate x plus 2 dx. So this is just a single function, so you can integrate this one directly. So you will have 1 over 3. So integrate x will give you x squared over 2 plus 2x. Okay, so therefore you will have x squared over 6 plus 2 over 3x. So this is your u. Okay, so now calculate your v. So your v is equals to integrate. So your y1 is equals to exponent x. Again your fx is x plus 2 ex over a is equals to 1. Your w is equals to negative 3 exponent negative x dx. Okay, so again here factorize your constant, so you will have negative 1 over 3. Why you have negative here? Because this one here plus sign. Okay, as for w, you have a negative sign here, so that's why negative negative will give you positive. Okay, so let's proceed. So simplify the exponential first, exponential function. So x plus x will give you 2x over x plus 2 divided by e negative x dx. Okay, so again use the properties here. Okay, so you will have equals to negative 1 over 3. So e2x minus negative x times by x plus 2 dx. So negative negative will give you positive. So therefore you will have negative 1 over 3. So integrate e3x x plus 2 dx. Okay. So can you integrate this one directly? You can't do so since you have a multiplication of two functions here, exponent and polynomial here. Okay, so refresh back what is technique of integration that is suitable to solve this kind of problem. If you have a combination of low-pack polynomial and exponential, so you will use tabular method. Okay, you can also use by parts, but tabular method much more easier than by parts, so just use tabular method. Okay, so let's proceed with this one. So you have to use tabular method for this one. Okay, so you will have, so tabular method you have low-pack. So which one come first? Polynomial, because you have x plus 2 and this one is exponential, which is e3x. Okay, so this one will be your u and this one will be your dv. You are going to differentiate this one and you are going to integrate this one. So this is your tabular. So your sign plus minus sign, this is differentiate and this is integrate. So you are going to differentiate x plus 2 and integrate exponent 3x. So remember, in the previous chapter I already revised you regarding the tabular method. So this is case 1 tabular method, whereby you can differentiate this one until 0. So you will integrate this one correspondingly. So you will have negative here. So x plus 2, so differentiate x will give you 1, differentiate 1 will give you 0. Okay, so now your problem is this one. So integrate exponent will give you exponent and you have to differentiate power here, 3x, so will give you 3. For differentiation process, 3 you will multiply by 3, isn't it? But for integration process, you have to divide by 3. So therefore you will have 1 over 3 exponent 3x. So again integrate this one. So 1 over 3 is a constant. So again you will have 1 over 3. So 1 over 3 times 1 over 3 will give you 1 over 9 exponent 3x. Okay, so what is your result from your tabular method? Please remember your negative 1 over 3 that you factorized earlier. Okay, because now you're going to expand with the result that you get from the tabular method. Okay, so you will have negative 1 over 3. Okay, so what is the first function? Positive 1 over 3 exponent 3x, x plus 2. 1 over 3 exponent 3x, x plus 2 minus 1 over 9 exponent 3x. Okay, this one. Okay, so expand and simplify this one will give you negative 1 over 9 exponent 3x, x plus 2. So negative negative positive, 1 over 9 times by 3 will give you 27 exponent 3x. So this is your v. Okay, so Therefore, you can have your yp by using this one, uy1 plus vy2, because you already have your u and v, and your y1 and your y2 is based from your yh. Okay, so this is step 5. Okay, so therefore your yp is equals to uy1 plus vy2. So this one is equals to, so what is your u? So your u is equals to x squared over 6 plus 2 over 3x. So your y1 is equals to exponent x plus, what is your v? So the whole function here, so negative 1 over 9 e3x x plus 2 plus 1 over 27 e3x times by your y2 is equals to exponent negative 2x. Okay, remember in your first step here you already decide what is your y1 and y2, so you have to stick with your y1 and y2 until the end of the solution. Okay, so expand this whole expression will give you your yp is equals to 1 over 6x squared ex plus 2 over 3x ex minus 1 over 9 x plus 2. This one here exponent times by exponent, so we have to add a power, so 3 minus 2 will give you ex. Okay, plus 1 over 27. So again here exponent times exponent, so 3x minus 2x will give you ex. Okay, so what else you need to do? Or you can expand this one, or you just can leave it as this one. This one is x plus 2ex. So if you're going to expand this one, you will have 1 over 6x squared ex plus 2 over 3 x ex minus 1 over 9 x ex minus 2 over 9 ex plus 1 over 27 ex. So as you can see here, there are a few functions that we can simplify. So the first one is with the coefficient of x ex. Okay, so you have 2 over 3 minus 1 over 9. So this one will give you 5 over 9. So this one you just copy back, so you will have, okay, sorry, so you will have 1 over 6 x squared ex. So 2 over 3 minus 1 over 9 will give you plus 5 over 9 x ex. So another function that you can simplify is this one, where you have ex and ex here. So negative 2 over 9 plus 1 over 27 will give you negative 5 over 27. So you will have minus 5 over 27 ex. So therefore this is your yp. So you can write your general solution. Now y is equals to yh plus yp. So your y is equals to, so what is your yh? Aex. You have to take this one as your yh, okay? Aex plus be negative 2x, not this one. Okay, you rewrite it as this one just to get your y1 and y2. Okay, so you will have Aex plus be negative 2x, and your yp is equals to 1 over 6 x squared ex plus 5 over 9 x ex minus 5 over 27 ex. Okay, so if you have an initial condition, so you have to get the value of a and b. Okay, so we are done with second example. So in my next video, I will explain to you the next example. Okay, so stay tuned. Thank you guys.